And finally, we talk about the calculus of polar curves here in Calc 2. I'm going to break this into two videos, one dealing with the length of a polar curve, and the second one is going to be longer. It's going to be about calculating areas. In each case, I have to develop why it is we do what we do. So let's go to the length of curves. We talked about parametric, we talked about rectangular. Now we're talking about polar, where you have a function r is some sort of function of theta again. Okay, we have a length of curve from parametric. All right, from parametric equations, we have x of t and we have y of t. And what we found there was that the length of curve was the integral from a to b, where t is the variable of integration. Again with the giant radical, right? So we have in here dx dt squared and dy dt squared as well, dt. Okay, so that's from parametric. And you know the trick we played last time, huh? You're ready for it this time though, aren't you? The trick we played was, remember that x can be written as r cosine theta and y can be written as r sine theta. So we can see these guys, we can look at this. R is a function of theta, remember. These are parametric equations with respect to theta. So we can actually go, okay, well then, the length of curve is, let's say from alpha to beta, they typically do. And this is where theta is between alpha and beta, okay? And we'd go in here, and we would take the derivatives of these guys. I'll write it out. We'll take dx d theta, square it, and dy d theta, square that, and there you go. That's not our formula, though. That's not our formula. It actually simplifies nicely, so let's get on this thing. Okay, we need dx d theta, we need dy d theta. So if x, do this in blue, if x is r cosine theta, we've done this for the slope of the tangent, didn't we? Then I'll say dx d theta is product rule. It is r prime cosine theta, and then minus r sine theta. And likewise, if y is r sine theta, same thing. Different result. So dy d theta is r prime sine theta, and then plus r cosine theta. Okay? And that is what we're going to put in there. It's equal to the integral from alpha to beta. And we're going to take these guys, square them. Okay? All right, so what goes in the first one? I don't know, don't care. It's going to be r prime cosine theta and minus r sine theta and r prime sine theta plus r cosine theta. And a miracle happens. No, we're going to do it. So we have, therefore, L is equal to the integral from alpha to beta. You know, life is full of these moments where it has to get worse before it gets better. We just got to be patient. So we're going to square this. I'm going to write r prime squared cosine squared theta. I'm foiling this one out right now. I have minus r prime r sine cosine, so two of them, minus 2 r prime r sine theta times cosine theta. And then the square of that term, so plus r squared sine squared plus r squared sine squared theta. Hey, who wants to go around again? Let's do it again. And it's almost the same. Well, kind of different. So we're going to go plus r prime squared sine theta. Double this one, so it's going to be plus 2 r prime r sine theta times cosine theta. And lastly, r squared cosine squared. So plus r squared cosine squared theta d theta. Now, boy, This reminds me of Calc 3, by the way. Weirdness like this happens, but wonderful stuff happens next. Ready? First of all, I'm so glad you came, but now here's your hat and what you heard. You're gone. The other part of this, I'll write this out so you can see that, because you're going to see it again and again in Calc 3, because, you know, this happens, is there's an r prime squared cosine squared. There's an r prime squared sine. That should be a squared. And so when you factor r prime squared out, you've got cosine squared theta plus sine squared theta. Why do you think I did that? Same goes for r squared sine squared, r squared cosine squared. So you go plus r squared, and then you have sine squared theta plus cosine squared theta. You see what? Do you see what I'm seeing, Chief? What do you see? I see all of this equals 1. All of this equals 1. That's Pythagoras. Here's your formula. The length is from alpha to beta, the square root of, well, how do you want to write it? I'll write it as r prime squared plus r squared d theta. I like that formula in that form. It tells me what to do. Take r and derive it, and leave r alone, and square them, and add them, and then square root them, and that's your length of curve. Isn't that like the distance formula right there? I mean, you know, it's like the hypotenuse of a right triangle. It's the square root of a squared plus b squared. But you integrate. Do you see this picture of all these tiny little hypotenusae, I guess, being added up? Okay, so I'm going crazy. I just have one example, and this video is over. So let's take a look at this guy. You know what this is? Cardioid. That's a cardioid. We're going to figure out the exact length of the cardioid, which is pretty awesome. So we'll do that. All right, so in order to do that, the game is L equals integral from what are the limits, big old square root, find r prime and put it there and square it, and then find r and square it and integrate with respect to theta. That's the game. Okay, so let's worry about r and r squared right now. So r prime, r is equal to 2 plus 2 cosine theta. R prime, okay, is equal to, the 2 disappears, right? And you've got a negative 2 sine theta. Okay, so in fact, I'll use this template right here. So r prime is minus 2 sine theta. And r is 2 plus 2 cosine theta. And the limits are, the limits. What's this guy? Maybe sketching will help. When, okay, you're 4, you're 2, you're 2, oh yeah. It's a cardioid. So if I want the entire curve, what are my limits of integration? You can use symmetry if you want to. I'm not going to be fancy. I'm just simply going to go round the horn, starting at 0, going all the way around to 2 pi. That'll do the whole curve, as theta does its thing. Okay, so we have, I'm going to go 0 to 2 pi. What else could you do? You could double 0 to pi if you wanted to. I don't want to. All right, so let's get after this thing. All right, integral 0 to 2 pi. And we're going to square stuff now, so we're going to get a 4 sine squared theta. That's all she wrote there. Plus, now we've got to FOIL this out. We get 2 times 2 is 4. Then we're going to get a plus 2 times 2 is 4. Doubled is 8 cosine theta. And then we're going to get, what else are we going to get? Plus 4 cosine squared, plus 4 cosine squared theta. D theta. Okay. Well, the same thing happens again as I try to simplify it, in that I see a sine squared and a cosine squared, and you got the same coefficient. So what I'm going to do is I'm going to pull out a 4 and leave behind sine squared theta plus cosine squared theta, and you know that that guy is going to turn into 1, right? Then we have a plus 8 cosine theta and plus 4 d theta. Okay, so to save time, well, I won't. So this is equal to the integral 0 to 2 pi square root, nothing but 4 there. I'm getting worried now. Plus 8 cosine theta, and then plus 4 again. Okay, d theta. So our integral becomes 0 to 2 pi. And under here we have 8 plus 8 cosine theta. 8 plus 8 cosine theta d theta. And I'm kind of bumming. Did I do something wrong? I don't know that I did. I took the derivative right. I got minus 2 sine theta. I've got 2 plus 2 cosine theta squared. Make sure that you got the right thing going on. So yeah, that's going to be 4 and 8 cosine and 4 cosine squared, and you got a 4 sine squared, and they combine to make 4, and that's another 4, and that's it. Yeah, you can take out an 8, which means you square root 8, and out front goes a 2 root 2. But I am saying right now 1 plus cosine theta. I don't know how to integrate that. So I'm kind of stuck. All right, let's see what I can do about that. I am wondering if I can figure out a way to do that. Well, I think I have to be kind of fancy here about the only thing I can think of. 2 root 2 outside, right? I did that right. 0 to 2 pi under the radical. We've done this in algebra and trigonometry before. We'll maybe try this. 1 plus cosine theta over 1, and then come along with your red marker and multiply top and bottom to make this guy go like 1 minus cosine squared theta. And downstairs is also, no, 1 minus, that's what I'm trying to achieve, 1 minus cosine theta. And then we have 1 minus cosine theta. Have you ever done this before? Does this look familiar? Okay, 2 radical 2 integral. Look at this, 0 to 2 pi. Okay, this is going to be, I think, okay. I've got a square root. I've got 1 minus cosine squared theta. Boy, all over 1 minus cosine theta. Okay, d theta. Okay. But upstairs, what happens? 2 radical 2. Now I got to be careful. It's going to be sine squared, and it's going to be, oh boy. You know what? Okay. Yeah. I got, boy, you got to be fancy on this one. I've got integral 0 to 2 pi, and then I've got the square root. Well, I've got basically the square root of sine squared. What do you think about that? All over 1 minus cosine theta. I think we're going to get somewhere with this one. But I got to be, here's the thing, I got to be careful. Integral 0 to 2 pi. I have to do this. I have to go absolute sine x when I square root that thing. 1 minus cosine, this guy's still under the radical cosine theta, d theta. Boy, this is taking a while. Why did I choose this one? Because I don't know why. Here's the thing. Let's go back up to that picture or draw another picture. If we do the top portion, right, and do the arc length of the top, sine is positive. Okay, that is scoped out from 0 to, that would be 0 less than or equal to theta less than or equal to pi. We have sine theta is greater than or equal to 0. So, but then we have to double it. We have to double it for the other piece. So I'm going to change my effort on this. I am going to double this, and I'm going to change the limit to just pi, and that means I can lose the absolute value. Wow, this is nuts. I thought this was a short video. Well, leave it to me. So our thing becomes 4 radical 2 integral 0 to pi sine x, or sine theta, I should say, sine theta over this radical, 1 minus cosine theta, d theta. What's the big deal? Are you kidding me? Look what we can do now. We can go like the following. We can go, let u equal 1 minus cosine theta. Therefore, du is equal to, derivative of cosine is negative. You get sine theta, d theta, which is all of that. Okay. Cool. Cool problem, I think. So we got 4 radical 2. Hey, do you dare to switch the limits? Do you? Let's do it. we're going to switch the limits. So theta, these are theta limits. If I plug in 0 there, I got 1 minus 1 is 0. If I plug in pi there, I got 1 minus a minus 1 is 2. Okay, and then I have 1 over radical u du. This is so fun. Oh my goodness. So we got 4 radical 2. This is really the integral from 0 to 2 of u to the minus 1/2 power du. So we're getting 4 radical 2 times u to the 1/2 over 1/2. So it's times 2 square root of u from 0 to 2. Boy, that all rhymed. And we're getting 4 radical 2 times 2. And then we have radical 2 minus radical 0. Look what we're getting. Oh my goodness, I got 8 times 2. I got 16 as an answer. Pretty cool. Wow. Okay, so not all of them are that nuts. That was trig intensive, but we figured out the length of a cardioid curve, which is historic moment. Thanks for listening, you guys. And we got a couple more in the next, one more in the next section about area. See you there.